Chapter 8 is all actually about mixtures, or in other words, solutions. And there are different types of solutions. So for example, one of the solutions that you're very familiar with is salt water. And in that, you don't see the salt separate and the water separate. It is what we call a homogeneous mixture or a homogeneous solution. On the other hand, you have sand and water, which you can see the sand separately and the water separately. And those types of things are called heterogeneous mixtures. They do not have uniform composition throughout their sample. And you can see the sand separate, the water separate. A solution is necessarily a homogeneous mixture. It is something that would be transparent, even if it's colored. It consists of two parts. So the NaCl, in the case of salt water, would be considered what is known as the solute. The water would be considered the solvent, and together they are called the solution. Solute, usually in the lesser amount. Solvent, usually in the larger amount. And an aqueous solution specifically is one in which water is the solvent. So sometimes you won't hear that water is the solvent. Usually it will be said in aqueous solution or blah, blah, blah. Then you would know that water is your solvent. Here are some examples of solutions that might not be necessarily stuff that you might think of as solutions. So a mixture of gases in your lung would be considered a mixture. You do not see the boundary between the two gases. You don't see oxygen, carbon dioxide, and nitrogen is different. And therefore, that would be considered a homogeneous solution of gases. Sodium chloride and water, which is what I have been telling you in this presentation so far, that's a more run-of-the-mill sort of solution where you have a solute, which is a solid, and then a solvent, which is a liquid or water. Alcohol solutions, they are other type solutions in which you have a liquid that is your alcohol dissolved in water, which is also a liquid, so you can have liquid-liquid solutions. And finally, you can have alloys, such as in your dental fillings, you have mercury and silver mixed together into a dental filling. And those are examples of alloys. Anytime you have any bronze sculptures or brass, those are all examples of alloys in which you do not see the two metals separately. You see the metals sort of together, and so they are homogeneous solid solutions. So this is an example of a gas. This is an example of a solid liquid. You could also have liquid samples, and then solid solutions are possible too. All right, so when they are not homogeneous, they could be either colloids or suspensions. An example of a colloid is milk. An example of a suspension is blood. So milk is a homogeneous mixture. You basically don't see anything going on. And after a while, if the milk is sitting in the fridge, it's not like you get settling. It's always homogeneous. But it does have an opaque appearance, so it's not transparent like the way sodium chloride and water is. Those are considered colloids. The particles themselves are of smaller size within them. So in milk, you have fat dissolved in the water. Those are the particles that I'm talking about, the fat particles. Now, a suspension, the major difference between a suspension and a colloid is once again size. The size of these particles is larger in a suspension, and what you could do is either you could filter or centrifuge and you would get those particles out. Whereas in a colloid, you couldn't simply centrifuge and it will not settle out. It will still be homogeneous. In terms of particle size, therefore, in solutions, the size is really small, 1 nanometer or less. You will not see any separation or settling, and those components cannot be separated by filtration. So you cannot filter NaCl and water to get back the NaCl and the water. With the colloids, those particle sizes are a little bit bigger. They go to the micrometer range. You cannot separate them using the common filtration techniques. You do not have much settling, but you do not see that transparency that you see in solutions. With suspensions, now these particles are much larger and those components can be filtered by centrifugation. Blood is a suspension. Again, you find that it is not transparent. It is kind of thick and nothing goes through it. You can see some particles, but those particles, when you centrifuge them, you're going to see sort of a heavier fraction go down and a lighter fraction of blood. You can separate out the plasma from the red blood cells. So basically, this next section is about electrolytes and non-electrolytes. An electrolyte is something like NaCl, which can split up into its constituent ions when dissolved in water. So NaCl splits up into Na plus and Cl minus when you put it into water. And what that means is, because what you need to conduct electricity is charges, and you are producing those charges by producing Na plus and Cl minus, the electrolytes are able to conduct electricity. On the other hand, something like alcohol, that is methanol, let's say CH3OH, it's a covalent compound. It does not split up into ions like Na plus and Cl minus. So in general, when you think of electrolytes, you have to think ionic compounds that can actually split up into ions, and then those ions are charged so they can conduct electricity. Whereas something like CH3OH, this is a covalent compound. When it dissolves in water, it stays as CH3OH. It doesn't split up, and therefore it does not conduct electricity, and that would be considered a non-electrolyte. A strong electrolyte, even within electrolytes, you have two separate classifications. One is a strong electrolyte such as NaCl, which dissociates. If you took one molecule of NaCl, or 5 molecules, all 5 of them would dissociate into Na plus and Cl minus. Whereas if you took acetic acid, which is a component of vinegar, vinegar is nothing but this acetic acid combined with some water, and acetic acid actually splits up into CH3COO minus and H plus. I would suggest you look at the equation carefully because in the next chapter you'll need it. The difference between these two is this guy, if I had 5 molecules of this dude, it does not dissociate into 5 and 5. A large portion of it will stay intact. Only about 1 molecule will dissociate into CH3COO minus and H plus. And so weak electrolytes, you will get fewer ions. They will conduct electricity, but to a lesser extent. Non-electrolytes are generally just covalent compounds. They do not conduct electricity. Examples are here in this table.